we're going to look at rational expressions. So that we need to be able to find the domain. In this first one, there's a couple things going on because we have the square root of x. Well, you can only take square root or even roots of positive numbers. Okay, so that means that our radicand, whatever we're taking the square root of, the radicand needs to be set greater than or equal to 0. Because we could take the square root of 0, that's fine. But we can't take a square root of something negative. Okay, so that's the numerator. And then the other issue, okay, so that's the one big idea, is set radicand equal to 0. And another one is that the denominator cannot equal 0. Okay, so if we had x squared minus 4 equaling 0, that would be undefined. So x squared when it equals to 4, so when x equals positive or negative 2, this is undefined. Okay, so if I was going to put these two pieces of information together in a graph, if I was looking at the domain, I would happily just be going along thinking I was fine, everything bigger than 0, except if I got to 2, I would have to skip over that and leave this little undefined place. So in set notation, it would say it's all the x's you want to give me, such that x is greater than or equal to 0, and x cannot equal 2. That negative 2 wasn't an issue anyway, because that's not part of it, that it can't be negative, okay, for the first condition. All right, and then we could write that in interval notation from 0 to 2, skip over 2, and head off towards infinity. So let's see, we found this is the domain. All of this is different ways of finding the domain. We wrote it in set builder, in interval, and we did the graph. Okay, so now if we're going to go and simplify this expression, what I can do is factor. So in the numerator, both of those are divisible by 3. So I'll go ahead and factor out a 3. And then in the denominator, everything's divisible by 9. So it would be x squared plus 2x minus 3. Okay, and then I can simplify my numbers here a little bit. So my numerator would factor as x plus 3, x minus 3. My numbers simplified down, so I just have a 3 in the denominator, and then I can factor x squared plus 2x minus 3, that factors as 2x. Oops. That factors as x times x, and then if we made this plus 3 minus 1, and then our x plus 3's can cancel, so I'm left with x minus 3 all over 3 times x minus 1. However, x cannot equal anything where it would give us something undefined in the denominator. So right here, right? Oh, that would create, if x is a negative 3, we would get ourselves a 0. Now you can write all of them that you want, like we could say, well, x can't be 0 or positive 1 from here either, but since it's obvious in the final problem, you don't have to write that one. It's just the ones from which you have canceled and you can't tell that you have a problem when x equals negative 3. That is no longer obvious in the answer. Okay, moving on, we're going to do a little division. So let's see, if I have a fraction divided by a fraction, I can copy the first one. I'll go ahead and factor that. Let's see. About x minus 3 and x plus 2. And x squared minus 1, that factors to x plus 1. x minus 1. Okay, I'm going to change to multiply times the reciprocal of that second fraction. Okay, so we changed from divide to the reciprocal, multiply times the reciprocal of the second fraction. Okay, then we'll go ahead and factor that. I'm going to run out of room here, but that's okay. So we have x minus 3, x plus 2. I'll just go ahead and copy that down. And then the second one factors to x plus 1 times x plus 1 all over x plus 2, x minus 2. And then we look for anything that might simplify. We have an x plus 1. I have an x plus 2. Okay, since those canceled out, I want to make sure that I show x cannot equal negative 1 and also negative 2. And then this finally simplifies down to x minus 3 times x plus 1 in the numerator, and then we had x minus 1, x minus 2 in the denominator. All right, so moving on to adding and subtracting, we need to get a common denominator. And to do that, it's helpful to factor first. Okay, so factoring down in that first denominator, we'd get x minus 2, x minus 1. Second fraction, we'd have x minus 1, x plus 1. All right, so both of them have an x minus 1, but this one has an x plus 1, so we need a common denominator. So we're going to give that first fraction an x plus 1, and let's see, we have an x now plus 1. Yep, this one doesn't have an x minus 2. So, okay, so giving ourselves that common denominator, now we are going to have x, distribute that in, squared plus x, and then this distribute the whole thing, that negative 2, multiply it times x and times the 2. So minus 2x plus 4 all over that whole denominator. And then that simplifies down to x squared minus 3x plus 4 all over x plus 1 times x minus 2 times x minus 1. And it's good just to think about maybe the numerator would factor and be able to simplify with something in the denominator, but that one doesn't look like it will. So we are done. All right. So these ones look impressive, these compound fractions. But we'll be able to simplify them pretty well. So I'm going to deal with all these little negatives. Okay, so that x to the negative 2 is the same thing as 1 over x squared. And then we have x or y to the negative 1, that's the same thing as 1 over y. Then in the denominator, x to the negative 1 is the same thing as 1 over x. And then we'd have 1 over y. Now, okay, if we had, this would be different if it was this x to the negative 2 times y to the negative 1 all over x to the negative 1 times y to the negative 1. That would actually be quite easy. You would just move this down. So you'd have x squared. This would move down. And these guys would move up. And these would simplify, right? It would be quite easy, but that's not our problem. That is not it, because what we have is quite a bit harder, because we have subtraction, addition, and subtraction. So if we were going to work this out the long way, we would get common denominators and simplify. The easiest way is just to multiply both by the least common denominator, which is x squared y. So if we take x squared y over 1 and multiply it in both the numerator and the denominator, that'll simplify pretty nicely. So let's see, we would get the x squareds would cancel, so we'd just be left with y. And then here the y's would cancel, and we're left with x squared. And then one of the x's would cancel, so it would be left with xy. And then here my y's would cancel, so I'd be left with x squared. And then just final thing, I can factor out an x down in the denominator. Okay, another way of looking at that, some students like to do it as the numerator divided by the denominator. So that's another method that works. The only thing with that is that you would have to get common denominators here, and then you could go ahead and do that division, multiply by the reciprocal of the second fraction. Okay, so that's your complex fractions. And then, let's see, I'm going to do one more this is quite complicated. Okay, what I'm seeing in the numerator, well, all of them have an x plus 3. So what I'm going to do is just factor here in the numerator. I'm seeing this is the smallest exponent. Okay, so in the numerator, I'm going to go ahead and factor that. X plus 3 to the negative 1/2. Out that comes, and I'm left with x plus 3 to the 1/2. I would be dividing by my x plus 3 to the negative 1/2. When you divide by a negative, it ends up adding. So out that factors x plus 3 to negative 1/2 plus 1/2. And my denominator I haven't touched yet. So let's see what happens. This is negative, it's multiplication, so that does just get to come down. So my next step is that x plus 3 to the 1/2 comes down and is positive in the denominator. And then let's see what we've got here. We've got x plus 3 to the 1/2 plus 1/2, that's just 1, and then minus x plus 3, negative 1/2 plus 1/2 is 0. So this then would become x plus 3 to the 1, that's just x plus 3, and then anything to the 0 is just 1. And then we get to add exponents down in the denominator, so it'd be 1/2 plus 2. And finally, let's see, we get x plus 2 in the numerator, and x plus 3 to the 2.5, that would be 5/2. And that is factored. All right, this really is very uncommon, but sometimes you're going to be asked to rationalize the numerator. Well, usually we're used to doing the denominator. So here, if I multiplied by square root of 2 plus square root of h plus 2, and I did that, well, I have to do what I do on the top, I have to do in the denominator as well. So then what would happen is we'd multiply that. It'd be square root of 2 times square root of 2, which is square root of 4. And then we'd have plus square root of 2 times square root of h plus 2. And then multiplying our negative square root of h plus 2, that would give us minus square root of 2 times square root of h plus 2. And then finally minus square root of h plus 2 times itself. So that's quantity squared. And down in the denominator, we just have h times square root of 2 plus square root of h plus 2. Okay, so these are adding up to 0 in the middle there. Square root of 4 is 2. And then squaring undoes the square rooting, and so we've got minus h plus 2. And just copy my denominator. And then just make sure that you distribute that negative. So we've got the 2's are going to cancel out, and you've got negative h over h times square root of 2 plus square root of h plus 2. Anything divided by itself is 1. So my final answer is negative 1 over square root of 2 plus square root of h plus 2. And that's rationalizing the numerator.